Hi, this tutorial covers the probability distribution. Alright, so let's start with a few definitions here before we actually make any probability distributions, just to make sure we have a good working definition of these things. Alright, so let's start with what's called a random variable. So a random variable is simply a variable whose value is a numerical outcome of a random phenomenon. Okay, so generally this is going to be if we have some sort of chance experiment where what we're measuring is a numerical outcome, we call that a random variable. Okay, now we want to make the distinction between a discrete versus a continuous random variable. So a discrete random variable is a random variable with a countable number of possible values. Okay, so if we were measuring the shoe size of the next person that walks through the door, shoe size is a discrete random variable, so in this case it'd be a discrete random variable because you can't have a shoe size of 10.345. Because of that, it is a discrete random variable. Okay, whereas a continuous random variable is a random variable with an infinite number of possible values. Okay, so if we think about somebody's true height, okay, there really isn't any limitation on how on what their height could be. I mean, they could technically be 5 feet, 3.745782 inches. Okay, we're limited by our measuring device, but in that case, it would be continuous. Okay, now we're going to concentrate on probability distribution. There can be probability distributions for both discrete and continuous variables. But to define a probability distribution, it's usually a table. Sometimes it can also be a graph, but it's generally a table that lists the possible values of x and their probabilities. Then a couple things about the probability distribution. All listed probabilities must be between 0 and 1, and the sum of all probabilities must be 1. Okay, you have to make sure that your table at the end, that all the probabilities do sum to 1. Okay, so let's take a look at an example that we're going to use to make a probability distribution. So our chance experiment is to roll 2 dice and sum the values shown on both dice. So what I'm going to do is I'm going to shake some dice, okay, and I end up with a 5 and a 2. So the sum there would be 7. Okay, if I rolled it again, okay, I got another sum of 7. Okay, if I roll again, I got a sum of 5. Okay, so let's define the variable x as the sum of the 2 rolled dice. Okay, so those values that I was saying would be a value of x. So now what are the possible values of x? Well, the smallest possible sum that you can have on 2 dice is 1 and 1, so that would have a sum of 1. Okay, the largest possible value is 6. And really, or excuse me, it'd be 6 and 6, so the largest possible sum would be 12. Okay, and then really you can have all of the values between 2 and 12. So possible values 2, 3, 4, 5, 11, 12. So you can have all of those values as possible values of x. So what type of variable is x? So since there are a countable number of outcomes, this is a discrete random variable. Okay, it's not continuous because there are a countable number of values. Okay, so now before we can make a probability distribution, we must consider all of the possible outcomes, which is known as the sample space of the chance experiment. Okay, so what I have laid out here is kind of a table that we're going to be able to look at all of the different values of x, so all of the different outcomes. Okay, so here I have die 1, so the outcomes of die 1, and then here I have the outcomes of die 2. Okay, so if I'm talking about this outcome here, that's a 1 and a 1, and in the boxes I'm going to write down the sum. Okay, so that outcome would be this one. 1 and 1 has a sum of 2. Okay, now 1 and 2 would have a sum of 3. Okay, that's going to be a different outcome than 2 and 1. Okay, because you can, 1 and 2 there is different than 2 and 1 here. Those are two separate outcomes. Okay, so we put a 3 here. Okay, 2 and 2 is 4 there. And then I'm just going to go through and fill out the rest of the table here. All right, so now that we have that filled out, you can see that it seems to be that the most frequently occurring sum was 7. Okay, we can see that there are 6 total ways of getting a 7. Okay, getting a 2 is pretty rare. So snake eyes is getting a 2, that's pretty rare. And 12, that's also pretty rare. And you can see that some are more common than others. We can also see that there are 36 possible outcomes. Okay, so 36 possible outcomes. Okay, so if we're calculating theoretical probability of a certain sum, it's always going to be out of 36. Okay, so now if we want to make our probability distribution, so this is a discrete probability distribution, what we're going to do is have 2 columns. We're going to have x, and we're going to have the probability of x. Okay, you can also draw it as like a vertical table, but I'm going to kind of draw it as a horizontal table. So then what I'm going to put here are the different possible values of x. Okay, and now I'm going to write down the probabilities within each of the values here. So since there was only one way of getting a 2, this probability is 1 out of 36. Okay, now if we look back at 3, okay, so there were 2 ways of getting a sum of 3. Okay, so this probability ends up being 2/36. Okay, then going back to 4. 4, there were 1, 2, 3 ways of getting a 4. Okay, and then looking ahead to 5, there are 1, 2, 3, 4 ways. Okay, so for 4, this would be 3 out of 36. This would be 4 out of 36. Okay, let's just check 6 and 7. So 6, there are 1, 2, 3, 4, 5 ways of getting a 6, and there are 1, 2, 3, 4, 5, 6 ways of getting a 7. And then you can see that 8, 9, 10, 11 kind of mirror what was happening with 2, 3, 4. Okay, so let's just fill out the rest of this now. So there were 5 out of 36. 7 out of 36 was 6 out of 36. Okay, and then this is when they started going back down. 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. Okay, and a lot of times what we can also do is convert these into decimal values. Okay, so we can easily do that if we wanted to as well. Then generally what we can do is also turn this into a histogram. Okay, so I'm not going to make the entire thing, but what we could do is we could set up our axes. This would represent x. Okay, 2, 4, 6. Okay, then on the so this would represent my sum, and then on this I can represent this with probability. Okay, and maybe I would go 0.1, 0.2, 0.3, and then what I can do is draw bars up to the different probabilities for each of these. Okay, but again, I won't continue doing that, but that's how we would make a histogram. Can also be a type of discrete probability distribution. Okay, and then finally, let's look at just a quick continuous probability distribution. So if we look at this example, a bus stops at a particular stop every 10 minutes. A rider shows up haphazardly at this stop. Okay, so not trying to catch any bus. Maybe they're out shopping and just haphazardly stopped at the stop. So what we're going to measure is the number of minutes a bus rider has to wait for the bus. Okay, so if we look at this, I have this broken up into 10 different intervals, 0 to 1, 1 to 2, etc. Okay, so now if they're just showing up haphazardly at this stop, and there are 10 categories, we know a probability distribution has to add up to 1. So this is going to be a uniform distribution where all of these probabilities go up to 0.1. Okay, so if we were thinking about how to graph this, what I would have is on my probability distribution, I'd have 0 to 10, and really what's going to happen is that this is just going to be a straight line from 0 to 10 where it simply goes up to 0.1. Okay, so both of these two ways are ways of drawing a probability distribution for a continuous random variable. So that has been the tutorial on probability distributions. Thanks for watching.